right, amazing students, we are finishing up 1.5 and we're starting with more of the word problems. I did quite a few of them on the first part, but now we've got a few more. And we're doing a commission problem. And this is problem 46 in your book. And it basically says that this fella's base pay is $1,270 a month. And the commission is 6% on sales. So he receives a paycheck for $3,154. And the problem is to find out how much did he sell that month. Okay, so we know that his commission is going to be 0.06 times his sales. Okay, and that we're going to have his original base pay is $1,270, and then when you take his base pay and then his commission, then he's going to get $3,154 at the end of that month in that paycheck. So the first thing we're going to do is try to isolate this variable, take away our $1,270 here and take away our $1,270 on this side, and so we end up with 0.06 S is, we subtract and we get a 4 and a 8 and an 8 and a 1. Okay, I'm pretty sure I did that right. And then we're going to divide by 0.06 and divide by 0.06. So I'm going to get my calculator here. I'm going to check that and then do that division. So I'm going to take 3154, take away 1270 and make sure I got that right. And I did. And now I'm going to divide that by 0.06 and I wind up with $31,400. So $31,400 should have been the amount of his sales. Okay, so that should be what we have. And then to check it, of course, we would take 31,400 and multiply it by 0.06 to make sure that we did indeed get the 1884, and we did. So he sold a lot of merchandise of whatever that was and got a lot of money. So that is problem number 46. And 47, no, we're doing 50 next. Okay, so this one in your book, problem number 50 is poster dimensions. So we're going to take the information in the problem was that the width is 2/3 of the height of this poster and the perimeter is 100. So we're just going to draw a little rectangular poster here, and it says the width is 2/3 of the height. So the height, we'll call that one, and the width is 2/3 of the height. So my goal is to get everything in one variable, makes it much easier, right? And then my perimeter is the distance all around. And remember, your perimeter is twice the, in this case, twice the height plus twice the width is the perimeter, or the sum of all the sides. Okay, so in this case, we're going to use, instead of the W, we're going to use the 2/3 H. So we're going to have twice H plus twice 2/3 H is P. And in this case, P is 100. Perimeter is 100. So that's what I have so far. And so when I'm going to make it a little simpler. I'm just going to divide everything by 2. I don't need to carry all those 2's because each one of these terms has a 2. So let's simplify that to H plus 2/3 H is 50. Why work harder than we have to, right? So now I'm going to put these two H's together because they're both like terms. So that's a 1H plus a 2/3 H. And remember, 1H is 3/3 H. So 3/3 plus 2/3 is 5/3 H is 50. Well, that was kind of sloppy. But when you're doing this now, when we're trying to get rid of a fraction, we can easily multiply by its reciprocal. So I'm going to multiply this side by 3/5, but I also have to multiply this side by 3/5. Let's get rid of all that there, right there. Okay, so I end up just getting H equals, and then 3/5 of 50, the 50 and the 5 are going to cancel with a 10, and I'm going to get 30. So let's check it. Let's put 30 here for the height, and then 2/3 of 30 would be 20. And when I add a 30 and a 30 and a 20 and a 20, I do get 100. So that is problem number 50 on your homework. Okay, so now we're with 53. Okay, so we have an airplane flying into a headwind, and the plane is going at 450 miles an hour in still air, and 30 miles per hour is hitting it in the nose. Okay, so it's got a 30 mile per hour headwind. It's flying into the wind or against the wind. So how long to travel 1,050 miles? So I put my distance right here. I put my rate, which is going to be the still air, 450. Take away the speed of the plane, which is decreasing the speed of the wind, which is decreasing the speed of the plane. And then my t. Okay, remember distance equals rate times time. So we're going to multiply these two together, but let's go ahead and simplify this. 450 take away 30 is 420. So let's make that simpler. And so we end up with distance is equal to rate times time. And we're trying to solve for t. So we're going to divide by 420. We're going to divide by 420. Okay, so on our little calculator, we got 1050 divided by 420, and we end up with 2.5. So 2.5 hours is the amount of time. Okay, so let's check that. If we do take the 420 and multiply it by the 2.5 hours, and so 420, we multiply it and we get the desired amount of time. So that one was pretty simple because you're just dealing with one situation there, not two that you're trying to put together. Okay, that was number 53. So number 56 here, we have 2 student loans, and the total of the 2 student loans was $9,000, and one was at 5% and one was at 6%, and after 1 year, Vera owes $492 in interest. What was the amount of each loan? Okay, so we could say we have principal 1 and principal 2. Okay, principal is the amount borrowed at each one of the different rates. So we'll make principal 1 at 5% and principal 2 at 6%. But we know that the principals added together give us $9,000. Okay, and we also know that our 2 interest added together, so interest 1 plus interest 2 is going to be equal to 492. And then we have this cool formula that connects the two. Okay, so we know that interest 1 is going to be principal times rate times time. And again, this is at the end of 1 year. So our time can be pretty much negated out of there. We just have a time of 1, and multiplying by 1 does not change anything. So we already know that this interest 1 is going to be 0.05 because it was a 5% interest times the principal 1. So I can take out interest 1 and put principal 1 times 0.05. Okay, and then I've got interest 2 is going to be principal 2 plus the rate of principal 2, which is 0.06, and interest 1 plus interest 2 is equal to 492. Okay, so I've consolidated my information a little bit and I no longer need this equation. Okay, but when you look at the two of these, I've got a principal 1 and a principal 2 that add to 9,000, and then I've got a percentage of each one of those that adds to 492. I still have two variables, which is not ideal. So I'm going to take this equation and I'm going to solve for one of those variables. I'm going to choose to solve for P1. Okay, so I'm going to say P1 is equal to 9,000 take away P2. 9,000 take away P2. Okay, so I have rewritten our information up here at the top of this board. So this is what I just solved for. I took this equation, P1 plus P2 is 9,000, and I turned it into P1 is 9,000 take away P2. So I got one variable in terms of the other. And so now I'm going to substitute this P1 into this equation. So I'll have one unknown. Okay, so this P1 is going to get expanded into this. So I'm going to get 0.05, and then P1 is now going to be 9,000 take away P2 plus 0.06 P2 is 492. So now I have one equation, one unknown, and I can solve this. Okay, so now I'm going to distribute through. And remember, to do this easily, remember this 0.05, if you cleared that decimal, move that, multiply that by 100, then you can cancel those two out, and it ends up being just a 450. A little bit easier to do the math on that. Minus 0.05 P2 plus 0.06 P2 is 492. Okay? So I'm going to subtract the 450 from both sides, get rid of that. Okay, so that's going to leave me with this right here, which is just 0.01. So I got a negative 0.05 P2 plus a 0.06 P2. If I do that math, I get a 0.01 P2 is equal to, because that cancels out, is equal to 42. Okay, so now I'm going to divide by 0.01 or multiply by 100. Either one of those is going to do it. If I'm doing it with without a calculator, I would definitely just multiply both sides by 100, wouldn't you? Be a little bit easier. So multiply both sides by 100, and that's going to clear out that decimal, and we're going to get P2 is equal to 4200. So she borrowed 4,200 at P2. So P2 is 4,200. And then when we plug 4,200 right here, then we're going to take 9,000, take away the 4,200 is going to be 4,800. Okay, and then we can check to see if this is true. So since the P1 is going to be, all right, so we said this minus this was 4,800. So we'll put that right here on top of P1. So if we take 4,800 and multiply it by 0.05, let's do that real quickly. So 4,800 times 0.05, I get $240 from this one. Okay, and then I'm going to take this one and take the P2, which is 4,200, 4200 times 0.06, and I get 252. Okay, so if I add 240 and 252 together, I do get 492. So I know that I got it correctly done. So that was a lot of work, but we got the right answer. And one account was 4,800 and the other account was 4,200. So there's your screen so that you can copy all of that. So we just have a couple more little problems that I want to work for you, and then we'll be done with 1.5. Okay, so for the last couple problems here, we have a traveling downstream problem, and our kayak goes 14 kilometers per hour in still water, and we have a current of 2 miles per hour that is, we are flowing with the stream. We are going gently down the stream, so we're with the current. So now if we do our distance, rate, time chart, our distance we want to travel is 20 kilometers, and our current is going with us, and so it's 2 kilometers per hour, and we were already in still water, which is kind of funny because the kayak doesn't really go anywhere in still water unless you're paddling it, but you're paddling at a certain rate, 14 kilometers per hour, and then you've got this 2 mile per hour current going with you. So now we're going 14 plus because the current is with us, and we're trying to find the time that it would take us to do that. So we end up with 20 and 16, and we're going to end up with distance is rate times time. 20 is 16 times t, and so we're going to divide 20 by 16 to get t, and when we simplify by 4, we're going to get a 5/4. So it's going to take us 1 hour and a quarter, okay? So 1 1/4 hours in order to get there. So if I take the equation and I put in 1 1/4, then I would get 16 plus a quarter of 16, which would be 4, and 16 plus 4 is 20. And that is problem number 64. And now we are done with that slew of word problems. And the last two are very simple. We're going to be done with 1.5. We're just trying to find the zeros of the function. Now remember, the zeros of our function are where it crosses the x-axis. It is where the function value, which is what your y, is 0. And that happens at the x-intercepts. So what we're really trying to do is find what is the x value of the x-intercept that makes the y 0. So here in this one, we're going to plant a big 0 there where the y is. And we're going to solve for what value of x makes that 0. So we're going to subtract an 11, and we're going to get a negative 11 here is equal to a negative 2x. And we're going to divide by 2, negative 2, and divide by a negative 2. So we're going to get x is 11/2. Okay, so if we go back and check that, we're going to plug in 11/2 right here. And if we multiply 11/2 times a negative 2, the 2's will cancel, but I'll get a negative 11 plus an 11, and that gives me the 0 that I wanted. So my x-intercept is 11/2 0, but my 0 of the function is just 11/2. Okay, so here's another problem right down here. Okay, and we're trying to do the same thing here. Find the 0. So we let y be 0, and 2/5 x minus 10. We're going to add the 10. We're going to add the 10 over here, and we're going to get 10 equals 2/5 x. This cancels. Okay, so here I'm just going to multiply by 5/2 on this side. And I'm going to multiply it by 5/2 on this side. And then the 10 divided by 2 is 5. 5 times 5 is 25. And so I get x is 25. Okay, so if I check that and I plug a 25 right here with the x, then the 25 will cancel the 5, and 2/5 of 25 is 10. And 10 take away 10 is 0. And there you have the last of 1.5, and I managed to finish it before my grandchildren walk in the door for hamburgers. So I'm going to get all this online for you tonight, and this is Mrs. A, and may God bless your day.